Section, I'm going to go over the Electrofisher settings. So you can see here, this is what the control panel of the Backpack Electrofisher looks like. So there's different buttons. You can go through the menu, you can set the pulse type, volts, frequency, duty cycle. So these 4 components here are what we're going to be going over in this section. So operating a Backpack Electrofisher is a lot more complicated than just going in and starting it. So the first place to kind of start is looking at the different types of electrical waveforms. So we have 3 different types of electrical waveforms. There's direct current, DC voltage, alternating current, AC, and then pulse direct current, which is also a DC current. So for direct current, DC, shown here at the top, you basically have voltage, which is, you could think of it like the electrical pressure, so how much electricity is being put out by your unit, is constant over time. So this is basically just a constant amount of current being applied to the water. This is definitely the less dangerous option in terms of human health. However, it has pretty poor capture efficiency, so there's trade-offs, right? It's less dangerous, but it's not going to be as effective at capturing fish. For AC voltage, this is a waveform that alternates in time. So you have this kind of wave pattern here of high voltage and low voltage. AC currents are really dangerous and they have really good capture efficiency. So there's, again, a trade-off. A lot of human health concerns, but they're super great at capturing fish. And then lastly, down at the bottom, we have kind of the intermediate between the two, which is pulse direct current. So pulse direct current is also a direct current, but what it does is it applies that direct current in pulses over time. So basically the unit turns on, it applies voltage as a constant, and then it turns off. It applies voltage, then it turns off. And this is really the happy medium between the two. It has pretty good capture efficiency, and it's moderately dangerous, but acceptably dangerous. So you often see backpack electrofishers using either pulse direct current or direct current, with pulse direct current being, in my experience, the more common type of electrical waveform. So voltage, like we just talked about in the last slide, is you can think of it like electrical pressure. It's how much pressure is being pushed out of your system, and it's basically the height of the waveform. So it's like how high this waveform is. And as a side note here, I'm not an electrician and I don't have a whole lot of knowledge about electricity, and I don't expect you guys to have tons and tons of backgrounds about waveforms and voltage and stuff like that. But I just want you guys to understand the basics of what these are, and more so I want you to understand how to apply these settings in the backpack electrofisher. So don't feel like you need to totally grasp fundamentals of electricity here. It's not really what I'm going for. So all you really need to know about voltage is it's basically electrical pressure, how much electricity is being put out by your system, and that it's measured in volts. For backpack electrofishers, we're looking at the 50 to 900 volt range, 50 being the lowest volt range, whereas 900 volts, if you're operating a backpack electrofisher on full setting on 900 volts and you were in the water without any sort of protection, it does have the ability to be lethal. Usually you're not operating backpack electrofishers anywhere near 900 volts. So usually we don't have to worry about that. So another component or another setting that you'll need to set on your backpack electrofisher is the frequency. So remember when we talked about pulse direct current, that voltage is not applied constantly. It's applied on and then it's off, and then it's on and then it's off. So frequency is the number of pulses per second. So it's the number of times that current is on in a 1 second interval, and it's measured in hertz. So if we have time here on the x-axis, 1 second, a 10 hertz is going to be on 10 times, whereas a 20 hertz is going to be 20 little zaps, so more pulses per second. The higher the frequency, the more effective the backpack electrofisher is at sampling fish. But also if you turn the frequency up too high, then you're gonna barbecue your fish. So again, there's a compromise to be made here. A duty cycle is the percent of time that voltage is applied, and this is measured as a percentage. So when you think of frequency here, that's just the number of times voltage is applied, whereas the duty cycle is like the fatness of these bars. So basically how long is the voltage on versus off. So if you have a 75% duty cycle, it's going to be on, then off, then on, then off. So that means over the span of 1 second, it's on a total of 75% of the time and it's off 25% of the time. If you have a 15% duty cycle, it's only on for a short period of time. So these are like really brief bursts of voltage. So both these two examples here, they have the same frequency. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are both a frequency of 10. So 10 hertz means there's 10 little on pulses per second. But the 75% duty cycle, even though they have the same frequency, this one's going to be a lot more electricity being put out to your system because it's on for longer for each of those frequency cycles. Conductivity is not something that you set on your electrofisher, but it is something that you do need to take into consideration when you're doing your backpack electrofishing setup. So conductivity is, again, related to salinity. It's the ability of water to pass an electrical current. We've talked about conductivity in the past because conductivity is often used as a proxy for measuring salinity. Conductivity is also used in freshwater systems as a measurement of water pollution, pesticides, herbicides, things like that. What conductivity is really getting at is how many ions are in the water. So when you have a lot of ions in your water, ions being positively or negatively charged molecules or atoms, these conductivity or higher conductivity means you have more ions, which means that it passes electrical current more efficiently. So when you have high conductivity water, which is defined as greater than 50 microsiemens, you need to turn down the settings on your backpack electrofisher. Otherwise, you're going to totally fry your fish because high conductivity water is going to pass electricity a lot more efficiently than low conductivity water. Low conductivity water, you have to turn the settings up. Otherwise, you're not going to be able to stun the fish effectively because in a low conductivity water, without a lot of ions in the water, it doesn't really pass electricity very easily. And if you are electrofishing in glacier-fed streams, way up in the headwaters, the conductivity can actually be so low in those systems that you either can't use an electrofisher or you have to apply salt to the water in order to use it. So you can have problems with too low conductivity. So when you look at these high versus low conductivities, that is conductivity in freshwater. So high conductivity in freshwater, low conductivity in freshwater. The conductivity of seawater is orders of magnitude higher, 5 million microsiemens. That is way too high to operate an electrofisher, either a backpack electrofisher or a boat electrofisher. And because seawater is so salty, has high conductivity, high ionic compounds, ionic composition, and high conductivity, you can't actually electrofish in saltwater or really estuaries. If you did, it would totally kill all of your fish. So that's why electrofishing is really a freshwater fish sampling techniques. You do not see people electrofishing in marine or estuary environments, only freshwater environments, streams and lakes. And it goes back to this conductivity principle and the idea that you can't turn the voltage down low enough in a saltwater system to avoid killing all your fish.